All right, welcome back. Section 2.2. After this section, you are going to be able to describe and apply the 68, 95, 99.7 rule. We've already talked about that. Describe the standard normal distribution and perform normal distribution calculations. So means and standard deviations can be different values, but since the area under the density curve is always 1, a larger standard deviation will flatten out the curve. So the farther away you are, the more flat it's going to be. So this would mean that this is more variable. Okay, so the more spread out you are, the more variable, the less it's not as high of a peak. You go out farther on the tails. And this is going to be less variable. So it's less spread out. It's closer knit together. And again, the word for this would be more homogeneous. They're closer together. All right, normal distributions. You always want to identify the distribution by its mean and its standard deviation. And this is where we would do, n would be described by the mean standard deviation. And remember, when you have a z-score, when you're talking about z-scores, they have always made that where the mean is 0 and the standard deviation is 1. So here's again the 68, 95, 99.7 rule, the empirical rule. So hopefully you remember a lot of this. 68% of the observations fall within one standard deviation of the mu. So if you go out plus or minus one standard deviation, you're going to be within 68%. When you go within two standard deviations, so the mean plus or minus two standard deviations, you're at 95% of the data. And the mean plus or minus 3 standard deviations, you've incorporated 99.7% of the data. So if you're more than 3 standard deviations away, you are definitely really in the abstract world going on. Not very many people are there. The distribution of Iowa tests of basic skills for vocabulary 7th grade students in Gary, Indiana, Gary, is close to normal. Suppose the distribution, if you got that, I'll be surprised, is 6.84, comma 1.55. So this tells me that this is the mean and this is the standard deviation for the population. Sketch the normal density curve for this distribution. What percent of the ITBS vocabulary scores are less than 3.74, and what percent of the scores are between 5.29 and 9.94? All right, so if I wanted to give a little sketch, here I would put the mean in the middle, and then I'd take the mean plus 1.55 and minus 1.55, and I would take that again, keep going out, the 1.55, adding it on or subtracting it out. All right, so there's the sketch. So what percent are less than the 3.74? So right here, I know that 95% lie from here to here. So that means that this guy and this guy will be a total of 5%. So split that equally in half, and you'd get about 2.5%. Okay. Whoops. And then your last question. Sorry, I just lost it. Let me read it. It's getting covered by that. Says, what percent are between 5.29 and 9.94? So 5.29 to 9.94 would be here to here. So I know this is 68%. And then I know that 95 minus 68 would be all of this guy and this guy. Divide that in half, and you're going to tag that much more onto it. So adding those two together, what are you going to get total? So 68 0.68 plus 13.5, oops, would give me 81.5. Okay. The batting averages for Major League Baseball players in 2009 had a mean of 0.432 and a standard deviation of 0.034. Assume that the distribution is normal. Sketch a normal density curve for this distribution of batting averages. Label the points that are 1, 2, 3 standard deviations away from the mean. So do that first. What percent of the batting averages are above 0.33? What percent of the batting averages are between 0.398 and 0.5? See how you do. So here's my sketch. Part B would be 99.85. Part C would be 81.5. All right, so standard normal distribution. To standardize something means to put it into the z-score. To get the mean to be 0 and the standard deviation to be 1. So you can always get your value plugged in with the mean and the standard deviation to find its z-score. So this is what your density curve with the z-score, the standard normal distribution, would look like. So on your formula sheet, you can go to the z-table and find all kinds of fun z-scores. So go to that table and look about that. So each entry value for z is the area under the curve to the left of z. So for instance, if I found the z-score at 1.5, it is finding all of the area from the left up to 1.5. So let's say that I wanted to find the proportion of observations that are less than 0.81. So in my table, for my z's, I want to go to 0.81, and here I can see that I get out 0.7910. Now, tables are great. I love to use my calculator for this. So in your calculator, if you go second vars, that's the DISTR, so it's right to the left of the clear button, there's going to be a value for normal CDF. I'm going to talk about this more, but I just want to show you on this one as well, because this is how I love to do it. All right? So I can do my normal CDF. You're going to plug in the start, the end, the mean, and the standard deviation. So in this case, I'm going to do the normal CDF. Well, all the way to the left goes out forever and ever and ever. Even if you think, oh, you can't go lower than 0 because you're dealing with test scores or whatever. No, it goes all the way out to infinity in a bell curve. Okay, it never actually touches. It's like a horizontal asymptote. So you, in this case, are going from negative 999999999, which is basically big enough to say negative infinity, all the way to the end. So in this case, our end is 0.81. The mean of a z-score is 0. The standard deviation here is 1. Plug that into your calculator and see what you get. So negative 99999, comma, 0.81, comma 0, comma 1. And I got 0.7910299974. So it gives you a more exact answer than what the table will. So find these. And Again, when you see the z, you know the standard deviation is 0. Or sorry, the mean is 0, the standard deviation is 1. See if you can find these. Now, part A isn't too bad because it's to the left if you're going to use the table. So you can go to the table and find 0.79. Part B, using the table, is a little bit trickier because you want greater than that. So if you want to find greater than that, you know the total area is 1 minus the area to the left will give you the area that is bigger. Now, on A, if you wanted to do that in your calculator, you go normal CDF, negative infinity, so like negative 99999, all the way to 0.79 with a mean of 0 and a standard deviation of 1. Part B, if you want to put that in your calculator, now you're starting at 0.9 and you're going to infinity, so you could put like 999999999 with a mean of 0 and a standard deviation of 1. And you will get a more exact answer. So, using the table, if you wanted to find something, the z-scores that are between negative 0.125, or sorry, negative 1.25 and 0.81, well, first you're going to go and find 0.81, then you're going to go find the negative 1.25 and subtract it from the 0.81. Now, if you want to put this in your calculator, you would do the normal CDF from negative 1.25 to 0.81 with a mean of 0 and a standard deviation of 1. Easy. Now, beware though with the calculator. Beware. Okay, are you listening to me? Beware. If you use this on a free response question, you have to show this. Okay? Or you have to write in words what you have done. This answer right here will get you 0 credit. This is calculator speak. You don't want to write calculator speak on your test. Okay, it's fine for finding the answer, it's fine on a multiple choice, but if you are on the free response, you need to show all of your work. You need to describe what these values are, or better yet, make that graph. All right. All right, so here it is again in your calculator of how to go find the normal CDF. Make sure you do the CDF. Lower bound, upper bound, mean, standard deviation. And again, instead of using infinity, you can just use 99999 or negative infinity, negative 99999. Okay? All right, so try that one on your calculator if you haven't already. And I got 0.5855. Okay. Keep going. Now again, always draw the picture or be very specific in stating what everything represents. Do your calculations, look at the table, or find the normal CDF. Only after you've stated everything or drew your picture. Okay. At the end, write your conclusion in context. This is key. In context of the problem. So what does it actually mean with what's happening in the problem? Okay. When Tiger Woods hit his driver, the distance the ball travels can be described by n parentheses 304, 8 parentheses. What does that mean? That part right there. So this tells me the mean. This tells me the standard deviation. So what percent of Tiger's drives travel between 305 and 325 yards? I bet you can find this now. Draw a picture. You can find it with your chart if you'd like. If you want to do that, you're going to have to convert this to a z-score. This is not given in z's because you don't have a mean of 0 and a standard deviation of 1. So first thing you'd have to do is convert everything to the z-score. So I'm going to convert my 305, I'm going to convert my 325 to z-scores. So if you do that, then you're going to end up with a picture like this. Now, I would not do all of that work if it was me. I would stay right here and then go put it in my calculator. And you'll actually get a more exact answer. So using the table, you get about 0.444. If you did your calculator, you get 0.4459. This is more exact, and this is just fine as long as you have your picture, okay? Or you've explained what all of these values represent and what you're doing when you do a normal CDF. All right. In the 2008 Wimbledon tennis tournament, Rafael Nadal averaged 115 miles per hour on his first serves. That's really fast. Assume the distribution is normal with a mean of 115 miles per hour and a standard deviation of 6 miles per hour. About what proportion of his first serves would you expect to exceed 120, and what percent of his first serves are between 100 and 110? See if you can do this now. I bet you're a pro. Let's see if you got those out. Okay, so now the second thing we want to do is to find a value when we are given a proportion. So sometimes we want to find the observed value that corresponds to a given percentile. So that means that, let's say they gave me the area under the curve and they said that that's like, I don't know, 0.21%. Okay, so 21% or 0.21. And they want to know what value corresponds to that. Then we're going to have to either go to table A and go backwards. So find the given proportion in the table and then go and find the corresponding z value, and that's just fine. Or in your calculator, you can do the inverse norm. So in the inverse norm, you put that percentile or the area under from the left, from the decimal. Make sure you write it as the decimal, okay? Then the mean, then the standard deviation, and it will tell you what that value would represent. So, according to a website, the heights of 3-year-old females are approximately normally distributed with a mean of 94.5 centimeters and a standard deviation of 4 centimeters. So what is the third quartile of this distribution? What is the 50th percentile? What is the 45th percentile? Okay, well, first you got to remember third quartile means what? 75th, right? Okay, so if you want to find what value corresponds, inverse norm, what value corresponds to the 75th percentile, or 75% falls below it, I'm going to use 0.75. Then it told me my mean was 94.5, and my standard deviation was 4, and I get out 97.19. Okay, try that with the other two. See how you do. I got 94.5 and 93.997-ish. Okay, normal probability plot. Last thing we're going to go over here. A normal probability plot, if they lie close to a straight line, then it's approximately normal. Otherwise, it can be skewed right or skewed left. Outliers are the ones that are not overall in the pattern.
probability plots will tell us whether our data is normal or not. Let's take a plot in a probability plot. And if our plot is roughly linear or approximately linear, then we can say our data is approximately linear. If our data is perfectly linear, then we say our data is perfectly linear. So to get these normal probability plots, you first got to put your data into the calculator. We'll do that by doing stat and then edit, and then you will enter your data set. Our data set is over here. We've got 5, 5, 6, 7, so we would enter 5, 5, 6, and we would just keep going like that. Once your data is entered, then we'll do the stat plot. So we need to turn the stat plot on, and we'll also need to select the probability plot option. To turn the stat plot on and view stat plots, we use second, and then the y equals key, which above that it does say stat plot. And then all of our stat plots are currently off. We're going to turn the first stat plot on, select enter to edit that first stat plot. And see how the cursor is flashing over on? To select it, all we need to do is press enter, and then it will turn from off to on. And then another thing that we need to do is choose the normal probability plot option. This over here is a picture of our options, and the option we want to highlight is the normal probability plot. It's right under the histogram. So we go and we select the normal probability plot and we press enter. Now we'll change our options. We want our list to be open and we want our data axis to be X and Y. X representing our data. And then we want to graph the plot. And we could just press graph, but I think to zoom in on the data, the best option is to choose the statistical zoom option. So we can press zoom, and then option 9, which is the statistics or the stat plot option. And we will see all of our data. And you'll notice that the data does go in a linear fashion. So we can say that our data is approximately normal.
All right, so here are a couple of probability plots. And we want to know which one would be skewed left versus skewed right. Oops. Okay, so here I can see that I have most of my data, and then I'm going to have some outliers going on here. So this is going to be skewed right. Here I have a few things, and then most of my data graphed. So this one would be skewed left. And feel free, if you want to learn more about this, to go on to that website. In summary, normal distributions, normal curves, we're going to do n, parentheses, mu, comma, standard deviation, sigma. We learned about the 98, 95, 99.7% rule. The standard has a mean of 0 and a mean of 0 and a standard deviation of 1. You can use table A, or you could do the normal CDF, and we learned what a normal probability plot is. So you made it through another module. Good job, and I'll see you in module 3, guys. Bye.